So, this is obviously a line. So if I want to write its explicit relationship, I want to use mx plus b, of course. So can you guys help me? What is the b?
B is 10.
10?
Yes.
B's the y-intercept, I agree. So we'll say y equals 10x.
Yeah, that's what I put.
Isn't the thing attached to x what you grow by? It's not where you start.
I did negative 2.
We start at plus 10.
I did negative 2.
Negative 2 over 1 sounds good. Sounds like it should be negative at least, right? I think Hunter's on the right track there.
Yes, it's negative 2 over 1.
Does it go down 2 over 1 like this? Down 2 over 1?
Yeah.
Looks like it. I think you nailed it. Negative 2 over 1. You could write the over 1, but really you should simplify that to negative 2x plus 10. So just remind yourself that the growth thing, or in this case the thing is shrinking by, is always attached to x. Why is that? It's attached to x because x is the container that says how many times you want to do it. You can do it once and you get 8. If you do it twice, what do you get on this line? If you go 2 for x, you get 6. If you go 3 for x, you get 4. If you go 4 for x, you get 2. That's why the growth rate is always attached to x, because x is the variable that lets you decide how far you want to go. 10 just says where to start from. Okay? That's it on that one. Let's look at another one. Okay, this one's also a line, so mx plus b. Lynn, what's this one start with? What's its b? Negative 12, very nice. So we'll have negative 12. Let's see, next good to go. Make sure some other people are good to go as well, though. Let's see, AJ, can you tell me what would it be? Is it growing or falling, first of all?
Isn't it like falling?
So when I saw her say falling, I saw her go like this. Should we ever read things right to left? Left to right, it's going up. The slope is positive.
Going up 20, I would
You got to find a point. So Hunter's found that point. Where's another point we can see clearly? I think maybe right here.
Yeah.
Or even better, I think right
Yeah,
here.
8, 2 and 8.
See how that's a clear point? You can tell the slope if you can see a clear point. You might have to find a clear point, just like on the quiz we just took. So I think it goes from negative 12 to negative 10. How much up is that?
2. Alan, 8.
Yes. So this should be 2/8 x, which I think reduces, you should reduce that to 1/4. There we go. Let's look at another one. Okay, this time we don't have an exponential. This time we don't have a line, we have an exponential. So what's the explicit form of an exponential? Remind me. Should be able to write that down immediately, yeah? That's the explicit exponential form. Okay. So what's a? Somebody tell me what a is. Miss Baker? So what's 5? Yes, a is the y-intercept, so I'll put that in. 5. What do you guys think this one is growing by? Remember, this time it's not growing in an addition fashion, it's growing in a multiplication fashion.
By 2.
Nick, you have an idea?
By 2.
You guys both think by 2?
Yeah, 5 and 5 is 10.
Let's just check it. So they guessed, let's try it. Maybe that's true, maybe it's not. So they're thinking this then, right? So where is the real clear point? You're saying 10?
Yeah, if you
Larry
go from-
says he can see this point real clearly. You guys hear him?
20.
Another point you can see real clearly. Look, is that 20? Yeah, it looks like it. I agree.
10.
Either one of those would be a good test point. I'm going to pick Larry since he was first. So he says 1 is supposed to be 10. If I put 1 in here, is it? That's really just 5 times 2, which is 10. If I put 2 in here for x, what's 2 squared? Is 4 times 5 20? So that's clearly the correct choice. This is our exponential curve right here. That's it. And just like that one, I'm not going to pick anything super exotic. You should be able to guess it if you try. Let's look at the next one. Connor, scroll it. Oh, you're fine. So we've got a green exponential curve this time. So still AB to the x, right? I should have left that up here.
Yeah, you got negative 6 and negative 8.
What's up?
So the A would be -2x.
Negative 2. So we're going to go negative 2 for A. What do you guys think this one is growing, or I should say falling by?
By 3.
Powers of 2, powers of 3, powers of 4.
Times,
Here would be a good spot to check.
yeah, times 3.
Yep.
Yeah, it's 3. It's times 3.
Or right here would be a good spot to check.
Yeah.
Nothing.
So these guys, notice, they say powers of 3. How are they picking that power of 3 so easily? It's like multiplying by 3. 3 times negative 2 is negative 6. Times 3 is 18. You see how you can pick those out pretty easily if I pick easy numbers at least? And that's all I'm going to be doing during this unit. We're going to do harder numbers with these next unit and do some much more advanced things.
You just gotta
So-
remember science.
Yeah. It's not that bad, right? I mean, you can totally solve for these as well, but most of the time it's not going to be bad. Let's see if the next one is just as easy. Ah, we've got another line. So it's not this, it's mx plus b.
Okay. So it's down to
B would be 14, nice. What else? Down or up? Down, so you know this has to be negative.
minus 2.
Where's a spot we can see?
12.
5, I heard 5. So like 5 and... Looks like it's a little bit off.
It's 4.5.
But if you did that on my test and you were just a slight bit off, do you think I'm going to mark you off a lot of points? No. You got the right idea then.
It's 4.5.
It's right on 9?
No, it's missing again.
I think it's slightly off again. This is trickier.
4.5.
So maybe we could put, we're not exactly sure, maybe it's approximately. We could do that, right? We could say it's approximate. That'd be pretty close.
I would still go for it.
Looks like a little bit less than 5. We could really, if we wanted to be more accurate, say over...
Like,
maybe 4.5, 4.7, something like that. You could even be more accurate on something like that, yeah? Okay, that's the idea. Let me do a couple other problems before we close this one. I think you're going to see these on day 13's handout and on your exam. So, a couple new things.
oh, I have
This, guys, is of course the way to express any diagonal line. There's a couple exceptions that kind of need to be memorized or thought about with common sense. I really recommend common sense more than memorization. For instance, how do you graph this line? I'm going to do 2 different other lines with you. So what about this one? A horizontal line that's perfectly horizontal. Or what about a line that's perfectly vertical?
That was cool.
I think these are kind of exceptions. They're really easy exceptions, but you've got to know them. So I think you're going to run into them in today's practice a couple times. They'll definitely be on the exam. So you need to know a few different explicit formulas. This one for exponential curves. This one for lines. We've been practicing a lot with both now, so that should be easy enough. You also need to know horizontal and vertical lines. When you think about this, what's the only criteria to be on that line? There's only one criteria. You have to be how high?
4.
You have to be 4 high. So how do you say that with coordinates? Is it x that controls 4 high or y that controls 4 high? It's y. The equation of this line is just y equals, instead of mx plus b, it's y equals 4. Because no matter what, any point with a y-coordinate of 4 will be on that line. That's its only constraint, its only limitation to be a point on the line. If that makes sense to you guys. I think that actually satisfies mx plus b too, but I like to think about it differently, okay? It's up to you. What's the y-intercept?
4.
What's the slope?
0.
0, because it doesn't go up or down, it just goes over. So if you went 4 and then you put 0 for m, wouldn't it just be exactly this? I think that's completely consistent. A vertical line doesn't really work with mx plus b,
Would be x equals.
but the only criteria is that x has to be something. That's it. A vertical line is always x equals. So x equals isn't just like a one-dimensional solution point. It's also a line. And Jason, you got to know that. If you don't know that, next year you're done. So x equals is also a vertical line. What's this specific equation?
3.
1, 2, no, it's
3's
2
over
and a half.
here.
I mean,
Oh,
negative
yeah.
3.
X equals negative 3. Does that make sense? And of course, this could be decimals as well. You could have a line over here like, you could have a line like that one. That one would be x equals 3.5, or something like that. But if you see x equals by itself, that's also the equation of a vertical line. Oh my God, so important. That came up today in Algebra 2, and some people still don't have that totally sunk in. So very, very important that you remember x equals is a vertical line. And it's easy not to mix up, because if you think about it, all the x values of these points are the same, right? They're all negative 3. Y equals is a horizontal line. The y values are all the same. If you just use common sense, you won't mix them up if you actually think about a couple points on your line. You guys know what I'm saying?
Yeah.
Last thing, I'm going to do one more example of solving for y. So you guys definitely need practice with that. So let's do one more.
That explains how it originated. Wow.
I think this is the one thing we definitely need a lot more practice with. So here we go. There, I made up a line. I think I made up a friendly one. It's going to come out nice if I'm not mistaken. I need to get mx plus b before I can graph it. I'm shooting for this, in other words, so I
Subtract
can
9.
Subtract 9.
graph it.
Yeah, subtract x.
So I hear subtract 9. I agree mostly. I need to subtract that whole thing, not just the 9.
Well, subtract 9 all,
9x.
everything.
Subtract that thing. Yeah?
Yeah.
Move it over.
3y equals
I agree.
45.
15 equals 7.
These are apples and oranges. These are x's, these are integers. They don't play together. They're not like terms.
And then you divide the y thing
Yeah,
by
divide
Y
three.
still has a
Divide
3 on it,
everything by
right?
Yeah. So it'd be y
3, 3, 3.
equals
Y 15 equals minus 3.
15 minus 3x. And then, of course, I could graph that and say 15
Do that.
Minus 3.
down 3 over 1. That's going to be a pretty steep negative line. Let's do one last one. You guys seemed okay with that, but I know it's not all of you. It needs to be all of us. So let me make up one more. How about let's go.
Add 14x itself and 35.
Okay, remember, you're shooting for y. It's not the first or second thing that you move. It depends what it looks like. You're trying to get y by itself, so I need to move that first.
you add it. You add 14.
So I added. Notice how I'm putting this off to the side. I think that really helps if you
7y
have a
equals
spatial issue.
5.
Notice the negative has not been touched yet. It's still attached.
Yeah. Equals 35 plus 14. Divided by
And now I need to get rid of this multiplication by dividing. If some of you are looking at this and thinking that says subtract 7, it doesn't say subtract 7, it says divide, right? So be careful with that.
y equals 5.
Negative 5.
Minus 2x.
Positive over negative, negative 2. So this guy would look like
Negative 5. Then you go down 2 over x. 1.
Down 2 over 1.
so another fairly steep negative line. Okay? I think that should be it. If you need more examples, go ahead and look at the PowerPoint that I'll post on Moodle. And we'll be looking at the game tomorrow. See you next time.
Sounded like a